Part 2, this is going to be topic 11, is acceleration in falling objects, or we call this free fall. If an object is falling and we're going to ignore air resistance. So sometimes things fall a little bit slower because they have shape, like a parachute slows down the rate at something falls. But we're assuming things are going to be in free fall. That's ignoring air resistance. Let's take a look at this picture right here. We saw this in class, and this is an interval picture. Every one of these represents a photo taken every, let's say, second. And we can see it's accelerating every second, 1 second, 2 seconds, 3, 4, 5, 6, 7, 8, 9, 10. Every second it's falling farther and farther and farther. That's how we know it's accelerating. It's in free fall. And it turns out that if we ignore air resistance, acceleration due to gravity equals 9.8 meters per second squared. So when things fall downward, if we ignore air resistance, the acceleration is always equal to 9.8 meters per second squared on Earth. It's based on gravity. We'll learn more about that soon. Let's take a look at an example. So if we drop a rock at 0, it has 0 meters per second. After 1 second, 9.8. 2 seconds, 19.6. 3 seconds, 4 seconds, and faster still. I think you get the idea. It's accelerating. It's going faster and faster and faster as it falls because gravity is always pulling it down more and more and more and more and more. So, if we look at a math problem, we have these formulas here. How fast is a ball falling? After. That means we want to find our final velocity as our question. After 6 seconds, we know the time equals 6 seconds. We're not given any more information, but we do know the ball is falling, which means the acceleration equals 9.8 meters per second squared. And we know that the starting velocity, because it says at rest, oops, can we undo that? We know the starting velocity, because it says at rest, is 0. I can only use a formula that has these things, which is this one. And I set it up. Question mark equals 0 plus 9.8 times 6 equals 9.8 times 6, 58.6 seconds. No, meters per second, because this is velocity. Without the units, it's incorrect. Okay. Next one. How high up? So we want to know how high up is a bridge if it takes 8 seconds for a dropped rock to hit the ground. So if we have a bridge and the river below, and it takes 8 seconds to hit the ground, we can actually find this height. So we want to know, what is our height? If time to fall is 8 seconds, dropped from rest, the initial velocity is 0, falling acceleration is 9.8, and that's what we need to figure out. Now, here's the trick. This is height. or this is our y, our up and down displacement. So we can't use this formula. We don't know our velocity final. We can't use any of these. So this one is the formula that we use for falling objects. And we know we need to find our final position. We know our initial position is 0. We know velocity initial is 0. We know time. We know acceleration. We can use this guy. It has everything we need to find this. So y equals 0 plus 0 plus 1/2 9.8 times 8 squared. Y equals 1/2 9.8 is 4.9 times 8 squared is 64. So our height equals 313.6 meters. So those were a couple examples of falling objects. There's more on the link on the website.